Alright, so I'm now realizing that I recorded the video without sound, so I'm going to do my best to talk over the video that I made for you guys with the problem set. This is Module 6, Lesson 5's problem set. So the question says use the coordinate plane to the right to answer the following questions. Use a straight edge to construct a line that goes through points A and B. Label the line E. So if you don't have a straight edge, you can use, if you're in Notability, you can use the pencil tool, or you can use, if you're on your paper, which most of you should have paper, you can use a ruler if you have a ruler. You can use a index card like Miss Ferguson did. You can use whatever you have available. So as you can see, I made that line that connected points A and B, just like the question asked, and I labeled it line E. When we're thinking about question B, says line E is parallel to the blank axis and is perpendicular to the blank axis. So parallel means that it can continue on forever and never touch the other thing. So that could be, if you're thinking about like a square, that's two opposite sides of a square. Here you can see I draw an example of parallel lines. If you were in my class, or if you were in my WIN group, you knew the little dance that I made that was frame the face, parallel lines. And that just has two hands on either side of your face, frame the face, parallel lines. And there I drew a perpendicular line. Those are special lines that connect at a 90-degree angle. So when they meet, they are at a 90-degree angle on each of those four sides. There I labeled the parallel lines PAR, just so we remember that those lines are parallel. I labeled my x-axis and my y-axis. My y-axis goes up and down. My x-axis goes left and right. You'll notice those arrows on each side of those. That means that they can go on and on and on forever and ever. My x-axis, I always remember that my x-axis goes from left to right because I can have my arms. If you make an X with your arms, you can fold those down really easy, and it shows a straight line going from left to right. If you have your arms in a Y, you can have your hands as those two top parts. You can fold your hands, and that's a straight line up and down. So that's kind of how I always remember my X versus my Y. When I label my coordinates, my X always comes before my Y. I can remember that Mr. Combs and Miss Facklin reminded me by saying that X comes before Y in the alphabet. So with coordinate pairs, it comes first. Line E is parallel to the x-axis because if we look at our parallel lines above, we can see that those can go on forever and never ever touch. When we're looking at perpendicular, it's perpendicular to the y-axis because they will meet at a 90-degree angle. Plot two more points on line E. Name them C and D. So what I'm going to do is I'm going to zoom in onto my graph, and I'm going to put, those two lines on there, or those 2 points, and label them C and D. Zooming out. Okay. Now, when I'm making my coordinate pairs, I always do those brackets on the outside first, or those parentheses, whichever way you call them, just because it kind of helps me with the placement. Then I'm going to go and I'm going to count to see where it lies with my x-axis and my y-axis, remembering that my x-axis comes first and that my y-axis is in that second position. So I'm going to count for A. That's 1. Or the 0 is that straight line right there. And that straight line at the bottom. It always starts at 0 on both of those. And it's 3 spaces in to the right. And I counted it again, 3 spaces in to the right. And it's 1, 2, 3, 1, 2, 3, 4 spaces up, so it's 4 on the y-axis and 3 spaces in. Now my B, I had to zoom in because my E is kind of on that. I'm using my graph below, so it says 10, and the B is 1 more space in, so it has to be 11 for my x-axis. And then 1, 2, 3, 4 spaces up again. For C, oh, it's still 4 spaces up. And for some reason I wrote X there. It should definitely say 5. But it's 5 spaces up and 4 to the right. I'm sorry, 4 up and 5 to the right. My D axis is once again 4 spaces up, and this one was 1 away from the 10, so it was 9. Question E says, what do all of the points of line E have in common? Looking up there, I want you to look at all of those points. We kind of talked about it a little bit. What is the point that all of those have in common? You'll notice that all of those, because they're on that same line, they all have the y-axis in common. So the y coordinate on each of those lines is all the same. They all have a y coordinate of 4. Awesome. Give the coordinates of another point that would fall on line E with an x coordinate greater than 15. Looking back at my line, they all have, and looking back at my coordinates, they all have a 4 as my y-axis. I made those little arrows to show that the line is continuing forever and ever and ever, and it won't stop. So, giving that coordinate, my y has to be 4, right? Setting that up. My y has to be 4, but my x just has to be greater than 15. So it can be 16, it can be 167, or if you're really crazy, it can be 1,671. All it asks is that it's greater than 15. All right, thank you so much for joining me for Module 6, Lesson 5. I'm sorry. All right, so question 2. Plot the following points on the coordinate plane to the right. Point P says 1 and 1/2 as the x-axis and 1/2 as the y-axis. Q says 1 1/2 as the x-axis, 2 1/2 as the right axis. R says 1 1/2 as the x and 1 1/4 as the y. It looks like I went ahead and labeled my x-axis and my y-axis, remembering that the axis comes first in a coordinate pair, and then the y-axis. My x is my bottom line, and I noticed there's my 1 1/2 for point P, and then the other point was 1/2. So I find where they meet, and I put my point and label that P. For my next point, it says 1 1/2 as my x-axis and 2 1/2 as my y-axis. So I go back to my grid, I find my 1 1/2, I find my 2 1/2, and I put my point down for Q. Next is R with 1 1/2 and 1 1/4. I want you to use your fraction knowledge, and use your grid to the right, your number line knowledge. Use your number line knowledge to figure out where that 1 1/4 goes. I know that 1 1/4 is going to be on the y-axis because it's in the y position. And it's going to be right in between that 1 1/2. It's a little bit less than 1 1/2 and a little bit more than 1. It still has 1 1/2 as that x-axis. So we'll find where those meet and label that R. My last point is 1 1/2 and 3/4. Once again, I want you to think about where that 3/4 is going to go on the y-axis. That's going to go, it's a little bit more than 1/2 and a little bit less than 1. So that's going to go right in between those as S. Use a straight edge to draw a line to connect these points. Label the line H. Remember, if you're on your notebook page or if you're on your problem set page, you can use a ruler, you can use an index card, you can use the side of a different page of paper. I'm labeling that line H, making it fancy like they did. In line H, x equals blank for all of the values of y. So I can look at my coordinates, I can look at my graph, and I can see which in line H, all of those have the same same x value of 1 1/2. All right. Question C says, circle the correct word. Line H is parallel or perpendicular to the x-axis, and so we're looking at line H's relationship with the x-axis. Just a reminder, those are what parallel lines look like, and these are what perpendicular lines look like. Parallel lines continue on and on forever without touching, and perpendicular lines meet at a 90-degree angle. So line H, it looks like that meets that x-axis, and it would be at a right angle, so it's perpendicular. The next part says its relationship to line Y. Those look like they would never meet, so they would have to be parallel. Question D. What pattern occurs in the coordinate pairs that lets you know that line H is vertical? So we're looking at those coordinate pairs and we're seeing what pattern do we notice? Well, all of the x values are the same. But the y values are all different. Sorry about the super spectacular handwriting. Don't have a stylus, so it looks so beautiful. Question 3 says, for each of the points below, think about the line that joins them. For which pairs is the line parallel to the x-axis? Circle your answer without plotting them. Explain how you know. So we notice that it's asking you for the line to be parallel to the x-axis. I want you to think about which ones you might know are parallel without creating points. Looking back up, I know that this line was parallel to the y-axis, and the thing that they had in common was the x-axis points. So all of the x-axis points were the same, which meant that the line was parallel to the y-axis. All right, so back to question 2. We noticed that all of the x-axis points were the same, and it led to a parallel line on the y-axis. So, okay. So we want it parallel on the x-axis. So if it's parallel on the x-axis, we have to pick the opposite value to be the same, which is in B. All of those y values are 9, which will lead to it being a parallel axis, or parallel to the x-axis. If you want, you can definitely draw those out and figure that out. I'd also like you to explain it in your own words why that worked. For question 4, it says, for each pair of points below, think about the line that joins them. For which pairs is the line parallel to the y-axis? Okay, so we're looking at lines that are parallel to the y-axis, which, if we remember, has to be that opposite value. So that value of x needs to be the same. They are the same in C, so C is our correct answer. Question 5 says, write the coordinate pairs of 3 points that can be connected to construct a line that is 5.5 units to the right of and parallel, noticing that parallel to the y-axis. So it's 5.5 units to the right of and parallel to the y-axis. That 5.5 units is very important. And parallel to the y-axis. Setting up my coordinate pairs for each of the points. Remembering that it has to be parallel to the y-axis, and it's 5.5 units to the right. To the right implies that it is to the right of the 0, so it's 5.5 units in on the x, and since it's parallel, all of those parallel to the y-axis, all of those x coordinates are going to be the same, and then the y can be really anything, can be 1, 3, and even 5.5, because those lines can go on forever. So, question 6. Write the coordinate pairs of 3 points that lie on the x-axis. So we're thinking about the x-axis that goes from left to right, starting at 0, going on to infinity, left to right, 3 pairs that lie right on top of it. So scrolling back up to kind of show you what the x-axis looks like again, noticing that it starts at 0 for the x. All of those are at a y position of 0. So let's go ahead and set those up and put 0 as my y-axis, because if it's all on top of the x-axis, it is 0 spaces up. And then across, it can be any numbers, so 1, 3, 27, all of those work, 270, 896, all of those would work for x lines because they're all on top of that x-axis. Adam and Janice are playing Battleship. Presented in the table is a record of Adam's guesses so far. He has hit Janice's battleship using these coordinate pairs. What should he guess next? How do you know? Explain using words and pictures. Okay, so you'll notice that I went ahead and created that graph using the points to the right. I remembered that the x coordinates come first, the y coordinates come next, and I went ahead and created that graph. I also, you'll notice, didn't put all of the lines in there. I just put the lines that were kind of important, the ones that I needed to help me place those points. I put a check mark for those points that actually hit, and an X for those ones that missed. That's kind of important because it helps you differ between the two types of points. I know that if those two hit, the battleship is about 3, sometimes it's 4 spaces, but 3 spaces. Battleships are also a straight line. They're not going to be in random places. I also want to make sure I'm hitting that battleship, so I'm not going to put a random point in the middle of a different spot, like over there. That would not really make sense as far as a next guess, just because I'm trying to hit that same battleship. So, all of the points are up there, so I kind of want to stick to somewhere in that region as far as the next guess. If I put a point right there that I noticed didn't hit, so I wouldn't want, I know my battleship isn't down right there. I also wouldn't want to put one to the left or to the right of that point, because the battleship is a straight line and it's not gonna have that point over there. I have those 2 that are in a row, so I know that my next point should be right around that. It's going to be at 312, so right above those 2 points would be one of the best guesses I could think of, because it's still got those 3 points in a row, and it's got them not in kind of a funky spot like right there. There could be a battleship over there, but we're trying to get the same battleship that we guessed so far. I want you to explain in your own words below why 312 makes sense as a guess, and thank you so much for joining me for Module 6, Lesson 5. Sorry for all the technical difficulties we had with this video, but if you have any questions,